My name is Dan Knighton. I'm the General Manager of Audio Precision. Today, I'd like to introduce a product developed by our sister company, GRAS Sound and Vibration. Audio Precision and GRAS Sound and Vibration are both part of Axiometric Solutions, and this is the first joint product we've brought to the market. What I have with me today is two new microphones, the 246AE, which is a half-inch free field pre-polarized microphone, and the 246AO, which is a half-inch pre-polarized pressure field microphone. Now, one of the problems that we have decided we want to solve is the general issue of how we get an acoustic measurement setup going. And like so many other people, the way almost every test scenario begins for me is with an acoustic calibrator. I place the microphone in the acoustic calibrator, turn that on, and capture the sensitivity of my microphone. That is certainly a classic way to do it and a pretty reliable way to do it, but it does have the problem that I need to have physical access to the microphone. Now, I can do this touch-free, if you will. In our system, we can also grab the calibration information via TEDS. I open the TEDS control panel in the APx500 software. I read the TEDS data, and I set the sensitivity. And I've achieved the same thing. I've captured the sensitivity of the microphone into our measurement setup. The one downside to capturing it via TEDS is TEDS has not actually measured anything. In this case, the microphone was calibrated at the factory in Denmark. The sensitivity information was programmed into the microphone, and we are simply reading that out. The next step, which is what I'd like to demonstrate today, is SysCheck2. So what SysCheck2 allows us to do is actively verify that the sensitivity of the microphone has not drifted since it was last calibrated. So if I go in the APx500 software, again into my TEDS SysCheck dialog, this time I'll select the SysCheck tab. I can select Run SysCheck. And unlike just reading TEDS data, this is an active process. There is actually a signal generator embedded in the preamplifier body of the microphone. That signal generator is in parallel with the output of the capacitor or the diaphragm of the microphone, and we actually sense any deviation in sensitivity. In this case, I decided that my acceptance level, or actually the default acceptance level, would be 0.3 dB. Now, it has failed. What the system has done is it's measured the value of the reference signal generator, compensated for the ambient temperature. There are actually temperature, humidity, and static pressure sensors embedded in this microphone as well, and algorithmically determined that we are not within 0.3 dB accuracy. Perhaps in this measurement setup, I'm prepared to accept a little bit higher deviation. So I'll set my threshold to be 0.5 dB. I can run SysCheck again. And now it has calculated that this microphone is in fact operating within 0.5 dB of its design or last calibrated sensitivity. And of course, the virtue of this is that potentially this microphone is not in a place that's easily accessible to me. Perhaps it's installed in an array or in a test fixture in a production environment, or just inside of a large chamber and you're standing outside of the chamber where the computer is located. In all those situations, SysCheck2 allows us to verify the accuracy of the entire signal chain without having to have physical access to it. So I've not only verified the sensitivity of the microphone, but explicitly I've also verified the cable between the microphone and the analyzer. And even the analyzer itself, by measuring that reference voltage, I've verified it as well. So I can now have 100% confidence that my analysis system is working correctly. I have all the benefits of doing a manual calibration with an acoustic calibrator, but in fact without having to physically touch anything. SysCheck2 is supported in Audio Precision's version 7 of our APx500 software, and it's supported using any of our analyzers with a CCP or constant current power measurement microphone interface. In this case, that includes the APx1701, the APx517, or any of our other analyzers when, again, combined with a 1701 or one of the newer GRAS Type 12 BA, BB, or BD microphone power supplies. If you have any questions, please feel free to reach out to your nearest GRAS or Audio Precision representative.